Hello everybody, it's chapter 9 which is on nuclear and particle physics. So there are 4 subtopics in this chapter. The first one is on binding energy and mass defect. Okay, so in this subtopic you have to be able to define and use mass defect, which is this formula here, define and use binding energy, this formula here, and second last, determine the binding energy per nucleon, which is basically this equation here. That's not really an equation. That is an expression? I'm not sure. And lastly, you have to sketch and describe the graph of binding energy per nucleon against the nucleon number. Okay, so you have to sketch it. Oh my god, so you have to memorize the graph. Right, so Einstein mass-energy relation. From the theory of relativity, it leads to the idea that mass is a form of energy. Okay, so mass and energy can be related by this very famous equation, E equal to mc square. So what is E? E is the amount of energy, m is the rest mass, c is the speed of light in vacuum. Okay, so that's the relationship between energy and mass lah. So that's why the idea that is mass is a form of energy, we can quantify it by using this equation here. Right, so first, let's look at the unit conversion of mass and energy. So we have electron volt, we have atomic mass unit, we have joule. But basically, ini dua aja lah. But, okay, so untuk electron volt, this is a unit of energy. It is defined as the kinetic energy gained by an electron. Kinetic energy gained by an electron in being accelerated by a potential difference of 1 volt. So 1 electron volt is equal to 1.6 times 10 to the power of negative 19 joule. 1 mega electron volt is equal to 10 to the power of 6 electron volt, which is equal to 1.6 times 10 to the power of negative 13 joule. Okay, so itu electron volt, ini mega electron volt lah. Mega is just times 10 to the power of 6 lah. Okay, so atomic mass unit, U is a unit of mass lah. Ingat electron volt ni energy, atomic mass unit ni adalah mass. Okay, untuk soalan dalam this chapter, kamu perlu tukar energy tu, jangan guna joule. Okay, then sometimes dorang tidak mau joule, dorang mau juga electron volt, sebab ini adalah unit of energy untuk this chapter. Macam tu. So kalau boleh kamu tukar dari joule tu, kamu tukarlah pergi electron volt, unless dia memang minta dalam joule. Okay, so it is defined, atomic mass unit ni defined as exactly 1/12 of the mass of a neutral carbon-12 atom. So 1U is equal to 1.66 times 10 to the power of negative 27 kilo. So 1U can be converted into the unit of energy by using the mass energy relation lah. So dia darab dengan the speed of light, dia dapat energy ni equal 1.49 darab 10 kuasa negatif 10. Maksudnya, satu atomic mass unit ni actually equal to 1.49 times 10 to the power of negative 10 joule. Okay? So untuk electron volt, lepas dapat dia punya value of U, lepas dapat joule, kita boleh convert ni joule ni jadi electron volt. So macam mana kita mau convert? Kita bahagi dia dengan 1.6 times 10 to the power of negative 19, which is the electron punya charge value. Okay, so dapat dah this value here. So this 931.5 ni, mega electron volt, is equal to 1 atomic mass unit. Ataupun dalam mega electron volt, dia 931.5 lah. Okay, macam tu lah. Okay. Penat pula bercakap, guys. Okay, barulah kita masuk dengan dekat mass defect. Okay, so mass defect ni apa? Mass defect ni adalah the mass of move. Okay, so mass defect ni, it's, sorry, my cat is on my iPad. Okay, so mass defect ni is telling us that the wait, sorry, let me restart. Okay, my god, this is so hard when I have a cat around. Okay, so mass defect is defined as the difference between the mass of a nucleus and the sum of the masses of the nucleons of which it is composed of. Okay, so sekarang ni mass of nucleus ni pula, dia mesti always less than its constituent nucleons. Okay, maksudnya this is the proton number. Is that proton number? I believe it is proton number. And then dia darab dengan mass of the proton, and then nucleon, and then darab dengan mass of neutron. Macam itulah. Dia ada bagi jugalah dalam exam. Tapi I believe it is in your front page of the formula sheet kalau tak silap lah. Macam ada juga. Okay, so maksudnya mass defect ni kan macam mana kamu kira? Kamu boleh kira total mass of nucleons tolak dengan actual mass of the nucleus. Okay, macam itulah cara dia kira kalau dia just bagi mass. Okay, so ada pula saya tulis sini. Okay, Z is number of protons, N adalah number of neutrons. Okay, so ini adalah formula dia lah. This one I'm not sure ada atau tidak dalam formula sheet. I don't really remember. But this one bukan je susah mau ingat je lah. Okay, so the reduction in mass is due to the act of combining the nucleons to form the nucleus, which causes some of their masses to be released as energy. Okay, so any attempt to separate the nucleons would involve them giving the same amount of energy lah. So this energy is called the binding energy of the nucleus. Nucleus pula. Okay, so that is mass defect. Binding energy pula. Binding energy is the energy that is required to break a nucleus into completely separated nucleons, also known as the energy released when all the individual constituent nucleons are brought together to form the nucleus. Okay, so they are the binding energy, and then after that they're separated. Okay, so since mass here is a measure of energy, the binding energy is the energy equivalent to its mass defect lah. Okay, so kamu boleh kira kalau kamu darab dengan C square, kamu akan dapat energy tu dalam joule lah. Okay, and then the mass defect ni kamu perlu guna in kilogram. Okay, alright. So ini mesti meter per second, ini mesti kilogram, ini dapat dalam joule lah. Kalau the masses pula dalam soalan tu dia akan bagi dalam atomic mass unit lah. Contohnya dia bagi 22.001133 U. Macam tu. Ini adalah atomic mass unit ataupun AMU. Okay, bila dia bagi unit yang itu, cara untuk kamu kira, kamu akan guna this equation. Instead of delta M darab dengan C square, kamu akan darab dengan 931.5 mega electron volt. So, bila kamu darab dekat guna 931.5 ni, kamu punya binding energy ni, unit dia akan jadi mega electron volt. Okay? Kalau kamu guna yang di atas ni, kamu akan dapat dalam joule. Kalau dia bagi kilogram lah. Tapi kalau dia bagi dalam atomic mass unit, kamu mesti darab dengan 931.5 mega electron volt. Okay? Okay. Lepas tu kita ada binding energy per nucleon. So the total binding energy of nucleus divided by the total number of the nucleons lah. So ini adalah the formula. And then what is this telling us? It is actually an indicator of the stability of a nucleus lah. So the nucleus that has a higher binding energy per nucleon is stable tapi limited to nucleon number yang less than atau equal to 50. Greater than or equal to 50 ataupun less than or equal to 80. So mostly the greatest stability is at this value of mass number lah. Okay. So this is the explanation of the graph. You can actually read that by yourself. I don't believe I have to read it. But what you need to know is the one that has the greatest stability is the elements at around this mass number lah. Okay, and then I have no idea how to tell you if they ask you to sketch it. Hopefully they won't ask, but I guess you can just sort of remember it's something like that, and that would give you marks already, I think. And then just tell them that the value around 50 to 80 is the most stable nucleus. And then the value of binding energy per nucleon increases rapidly with increasing mass number. And then tapi they reach a maximum at iron 56. So iron 56. Can't find it. But yeah. Okay, so that's just basically the explanation lah. Alright, so that is that. And then Okay, let's look at example. Right, example 1, we have to calculate the binding energy of an aluminium nucleus. Given the mass of neutron, okay, so that's just the usual, but they gave us the atomic mass of aluminium. Okay, right, so the binding energy is gonna be equal to, oops, that is too big. Binding energy is equal to delta M. So dia mau dalam mega electron volt. So we have to times it with 931.5 mega electron volt. Okay. So how do we calculate the mass defect? Mass defect is equal to ZMP plus NM and minus the mass of nucleus. Okay. So since the question didn't give us the nucleus punya mass, we have to calculate the nucleus mass lah. So how do we do that? Firstly, let me just tell you ataupun seingat balik lah apa this isotope number is telling us. This is the proton number. This is the mass number, which is A lah. Right, so since dari mass defect punya equation ni, kita perlu ada value of N. N here is equal to A minus Z. So A minus Z is 27 minus 13, which is equal to 14. So itu kita punya nucleon number lah. Right, so after that we have to calculate the mass of nucleus. So how do we calculate the mass of nucleus? Firstly, since this is an atom, the atomic mass, untuk cari mass of the nucleus, is we have to minus the atomic mass of aluminium tadi dengan the number of electrons. Okay, we know that nucleus is consists of proton and neutron. So kita perlu tolak dengan electron lah. So how do we do that is, since this is an atom, the number of proton is gonna be equal to the number of electrons. So kita tolak dengan Z darab dengan the mass of electron. Mass of electron sudah kena bagikan, which is this one here. So it's gonna be 26.98154 tolak dengan 5.48. Oops, lupa Z. So Z tadi is 13. Tolak dengan, this is just too small. Tolak dengan 13 darab dengan 5.48 darab 10 kuasa negatif 4. Okay, so from here, this is the nucleus punya mass lah. So the nucleus punya mass is gonna be equal to 26.9742U. Okay, so ini untuk, this is the step that you need to do kalau dia tidak bagi kita mass of nucleus. Kalau dia bagi kita atomic mass of something, we have to cari the mass of nucleus dulu lah. Kenapa kita darab dengan Z? Sebab untuk atom dia tidak charge kan sekarang, the number of protons will be equal to the number of electron. Okay, so the number of electron dalam nucleus tu kita darab dengan the mass of the electron. Okay, so kita sudah tolak electron, tinggallah proton dengan neutron number di dalam ni. Okay, mass of proton and neutron lah yang tinggal dalam the mass of nucleus. Okay, so selepas kita dapat mass of nucleus barulah kita boleh calculate lah. Okay, so this is 13. This is mass of proton, which is 1.007276 plus N, which is 14. This is mass of neutron, 1.008664 minus with, I'm just gonna make this a little bit smaller. Okay, so minus dengan 26.97442. Okay, so kita boleh dapat the mass defect to be equal to 0.24146U. Okay, so selepas dapat the value of mass defect, we can then calculate the value of binding energy. So binding energy is equal to delta M times with 931.5 So this will be in mega electron volt lah nanti. So I'm just going to write directly here. So this is 0.24146,931.5, which will then equal to 225 mega electron volt. Let me just double check. This one is 0.24146,931.5. 224.9, but basically that is 225 mega electron volt. So this is the binding energy of the aluminium nucleus. Right, so that is on example 1. Let's look at example 2. Now we have to calculate the binding energy per nucleon of a boron nucleus. Okay, in joule per nucleon. Okay, basically dia mau the binding energy in joule lah. Okay, so kalau in joule, later baru buat. Kita cari dulu dia punya mass defect. Okay, so for the mass defect sama juga dia punya formula, tapi again we do not have the value of nucleus mass. So mass of nucleus kita perlu cari sebab dia just bagi kita atomic mass of boron. So sekarang ni mass of nucleus is gonna be equal to mass of boron minus dengan Z darab dengan mass of electron. Okay, so what we are doing here is we are deducting or we are subtracting the mass of electron yang ada dalam the nucleus. Okay, so sekarang this is 10.811 minus, so what is the value of Z? Z is 5. So this is 5 times with the mass of electron, which is 5.48 times 10 to the power of negative 4, which will then equal to 0.1020 U. Okay, so that is the mass of nucleus. Okay, lepas tu barulah kita boleh cari the mass defect. So mass defect is ZMP plus NMN minus mass of nucleus. Okay, so this one is just 5. Oh, wait. This is 5. This is proton 1.007276 plus. So N is just, this is A, this is Z. So A is 10, Z is 5. So N is basically 10 minus 5, which is equal to 5. Okay, so this is 5. Mn is 1.008664. And then minus with the mass of nucleus, which is 0.01020. Okay, so the mass defect is then equal to 0.06950 U. Okay, so after getting the value of mass defect, we can then calculate the binding energy. So the binding energy soalan minta dalam joule. Okay, soalan minta dalam joule per nucleon. Okay, so maksudnya binding energy mesti in joule. So how do we calculate the binding energy in joule is we are gonna multiply it with the speed of light. Okay, so the mass defect ni kita darab dengan speed of light, which is 3 times 10 to the power of 8 square dia. Okay, so dapatlah binding energy dalam joule. Okay, wait. Oh, no, wait. We have to, yes, if we want, oh my god, my cat just gigit my sticky notes. Bella dia. Okay. Alright, so wait, sorry. Let me just refocus. Okay, first, so the binding energy, sekarang ni, the binding energy, if we want it in joule, we have to have our M in kilogram. Mana tadi tu? Okay, so our delta M ni sekarang perlu in kilogram. Tapi sekarang ni kita punya delta M is in U. So how do we convert this U pergi kilogram? So 1U is going to be equal to 1.66 times 10 to the power of negative 27 kilogram. So, kita perlu darab dulu delta M kita dengan ini. And then, baru darab dengan 3 darab 10 kuasa 8 sebab kita mau dia dalam kilogram. So, basically, we are just going to automatically put it here. 1.66 times 10, negative 27. And then, darab dengan 3 darab 10 kuasa 8 square. Okay, let me just write something here just so that you can't remember. So this one here is converting delta M into kilogram. Sebab 1U is equal to 1.66 times 10 to the power of negative 27 kilogram. Kita mau dia dalam joule. So semua mesti dalam SI unit lah. So this will then equal to 1.04 times 10 to the power of negative 11 joule. Right, so dapat sudah binding energy. Baru kita cari binding energy per nucleon, which is 1.04 times 10 negative 11 divided by A, which is 10. So you will get 1.04 times 10 negative 12 joule per, I don't like that way, per nucleon. Okay, so itu adalah jawapan example 2. Right, now let's look at example 3 where they give us directly the mass of nucleus. So, bila dia bagi kita directly mass of the nucleus, it is gonna be much more easier lah sebab dia lagi straightforward. So, sekarang ni kita perlu cari mass defect and binding energy for, I think that's, I don't know, maybe it's, I feel like it's chlorine, I'm not sure. I'm not a chemist, but I feel like it's chlorine. Yes, I'm correct. It is chlorine. Okay, so sekarang kita perlu cari the binding energy untuk the mass defect and binding energy for the chlorine punya isotope. Okay. So, sekarang ni, how do we start? We have to start with other mass defect lah. So, delta M is equal to ZMP plus NMN minus mass of nucleus. Okay, so sekarang ni dia dah bagi ke tidak mass of nucleus? Yes, dia betul dah bagi. So, kita tidak perlu carilah. And then, sekarang kita perlu cari the value of N. Since we already have Z, which is 17. N is A minus Z, which is 35 minus 17, which is equal to 18. Okay, so, substitute je lah dalam ni. Z is 17. This is 1.007825 plus 18. This is 1.008665 minus 34.96881. So the mass defect is then equal to 0.320144 U. So, if the question tidak mention in specific unit, kamu just keep it in U pun boleh juga lah. Tidak payah convert. After that, the binding energy is just, I suggest that kamu punya binding energy tu kamu akan guna electron volt saja lah. Jangan guna joule, okay? Because sometimes last time macam ada examiner that don't like it when it's in joule. Because they believe that for radioactive, it should be in electron volt lah. Mega electron volt. So, untuk binding energy, kita tukar pergi mega electron volt lah. So, kita darab kita punya mass defect ni dengan 931.5 mega electron volt. Okay, so this is 0.320144, 931.5. So, this is then equal to 298.21 mega electron volt. Right, so that is the binding energy. Okay, so some questions dia memang straightforward, dia tidak minta pun cari nukleus, dia bagi je terus. Okay, example 4 pula, what is the binding energy per nucleon for SN? I don't know what that is. Can't even guess. Oh, it's tin. So how do we, what's the full name of SN? What is it? Tin. tin je lah. Memang gitu je kah tin. Oh, memang tin ba pula? Astaga, what the heck? Oh, sorry. Okay, so it's just tin lah. SN tu tin, okay? This is tin. Mana tu kamu dah tu macam saya. Okay, so how do we find the binding energy per nucleon? Alright, so since they tidak mention, we're just going to assume that this mass of tin ni is the mass of nucleus lah. Okay, so that's just the mass of the nucleus. So delta M is equal to the usual ZMP plus NMN minus mass of tin nucleus. I'm gonna assume that's the nucleus punya mass lah. Okay, sebab dia tidak bagi di sini. And then Z is based on the isotope number. It is 50. The value of A is 120. So the value of N is 120 minus 50, which is equal to 70. Okay, so this is 50. This is 1.007825 plus, what is N? N is 70. 1.008665 minus dengan 119.902199. 1902199. Okay. Lepas tu kamu akan dapat mass defect. So the mass defect is equal to 1.095601 U. Okay, so that is the mass defect. So the binding energy, did I mention ka demo unit apa? Tidak. So it's up to us. So I'm just gonna use mega electron volt. Okay, so this is 1.095601 931.5. So you will get the binding energy to be equal to 1020.55 mega electron volt. And then they minta binding energy per nucleon. So that is EB over A, energy over A. So that is 1020.55 divided by 120. Okay, so the binding energy per nucleon is about 8.505 mega electron volt per nucleon. I guess this is much more better when you do that way. Sebab dia words kan? Sorry, word. It's a word. Okay, so that is example 4, and that is all for subtopic number 1.